Hello everyone. In this session, we will study how to form a circuit in a tool known as PhET Simulation tool. So here we are using the tool PhET Simulation, which is Circuit Construction Kit AC plus DC. So here, as we can see here on the right hand side, there are various components. This is a part where we have to track a particular component and form the circuit. Now we have to construct a DC series circuit, for example. So what I will do, I will take first of all a battery, which is a DC voltage source. Then in order to switch on or switch off the battery, I will take one switch. I will drop here. Then here two options are there to take resistance. Either you can take a electronic resistor here, or we can take light bulb as a resistance. Okay, so to have the visual representation, I will take the light bulb. So let me make some space here. So I will take 3 light bulbs which are connected in series. Now we have taken all the components. Now we need to join this. So for that I will require to take the wire. So I will take a wire and make connections. So all the 3 bulbs are connected back to back, one after other, so that they will form the series circuit. Now I can take one more wire here and directly connect like this, but just to have the good representation, I will take one more wire like this. And here also I will take wires in this way and make the final connection. So as you can see, our circuit is completed, but still no current is flowing and these bulbs are switched off. Reason is that currently switch is on here, so therefore no current will flow. So these blue dots is representation of electrons. In practical, there will be millions of electrons. Here as a representation, few electrons are shown. Now let us adjust or check the values. Now for that we have to right click and let us say first resistance is of 10 ohm. So let it be 10 ohm. I will click on show values in order to have the representation of the resistance value. Let us change this resistance value to say 15 ohm. I will keep it as 15 ohm. Random value I am taking, and this bulb, let us say it is having a resistance of 25 ohm. And we will click on show value, and the battery voltage, let us keep it as 100 volt. So our voltage, battery voltage is 100 volt. This resistance is of 10 ohm, or this bulb is having the resistance of 10 ohm. This bulb is having resistance of 15, and this is having a resistance of 25 ohm. Now what we will do, we will close this switch. As you can observe, as soon as I close this switch, electrons start flowing in this direction. Okay, and there is only one path for the flow of current because of the fact that these are connected in series. Now electron is flowing in this way, that is the anti-clockwise direction. So conventional current we are assuming to be flowing in clockwise direction. So this is the lifelike representation. Here you can see there is a option of lifelike. If I click on schematic, then I will get the schematic. So bulb will be represented as bulb itself. Here battery is represented as a long line and short line. Long line indicating the positive and short line indicating the negative. So electron always flow from short line to the long line, that is negative to positive. Actual current will flow from positive to negative. So let us keep it as lifelike tab. Now this we are assuming as an ideal voltage source, so therefore its internal resistance is 0. Now let us check various characteristics. Now first characteristic of series circuit is that current flowing through all the resistances connected in series is same. So let us do one more thing. I will just try to add one more wire here so that it will appear good. Now we were discussing, we have to check that current flowing through each resistance is same. So for that, so we need to measure the current. For that there is an ammeter. So there are two options, ammeter and non-contact ammeter. So I will choose the non-contact ammeter so that I can place anywhere without disturbing the connection. So first, if I see the source current, so source current is 2 ampere. That is the total current that is supplied by this particular source. Now if I calculate the current flowing through first bulb, then it is 2 ampere. Current flowing through second bulb, that is second resistance, again 2 ampere. And current flowing through third bulb, third resistance, that is 2 ampere. So our first characteristic is verified, that there is only one path for the flow of current and current flowing through each resistance, therefore it will be same. Now coming to the second characteristic, which says that total voltage will be equal to sum of voltages across each resistance. So for that I need to measure the voltage. So I will choose the voltmeter here. So this is a voltmeter, one red probe and one black probe. So if I connect red probe here and black probe here, so what does it mean? That we are measuring voltage of this point with respect to this point. That is the voltage of battery, which is 100 volt. Okay, so we are setting it as 100 volt. So capital V is 100 volt. So let me open one Excel page, and here capital V, it is 100 volt. We will cross check that this voltage V is sum of voltage across each bulb. Now let us measure voltage across the first bulb. So that is 19.999, that is close to 20. As you can observe, current flowing through each bulb is 2 ampere and resistance of this bulb is 10 ohm. So by Ohm's law, voltage drop across this, it will be 20. So 19.999, so close to 20. So let me put this value here, 19.999. Next, voltage drop across second bulb, V2, it is 29.998. So let me enter that, 29.998. And finally, voltage drop across third bulb, voltage across third resistance, as you can see, it is 49.996. You can verify. Resistance is 25, current is 2. So by Ohm's law, 25 into 2, that will be 50. That is close to 50. 49.996. 49.996. Now if I add these three, for time being, I will move this here. And if I add these three values, then it is 99.993, 99.993, which is close to 100. So our second characteristic is also verified, that is total voltage supplied is equal to sum of voltages across each resistance. That is the second characteristic. Now the third characteristic says that total equivalent resistance of circuit, series circuit, is equal to sum of individual resistances. Now how much is the individual resistance? 10 ohm, 15 ohm and 25 ohm. So if I add this, how much will be equivalent resistance? 10 plus 15, 25 plus 25, that is 50 ohm. So equivalent resistance should be 50 ohm. So how we can verify that whether it is 50 ohm? For that, what we can do, we can measure the total voltage, which is 100. Total voltage is 100. Okay, and divided by the total current. Total current is 2. So if I take V divided by I, total voltage by total current, that is 100 by 2, that will be 50 ohm, and R1 plus R2 plus R3 is also 50 ohm. So 10 plus 15 plus 25, that is also 50 ohm. So our third characteristic is also verified, that is equivalent resistance of series circuit is sum of resistance of individual resistor, or equivalent resistance is sum of individual resistances. Now coming to the fourth characteristic, which says that equivalent resistance is more than the largest. So equivalent resistance was how much? It was 50 ohm. So this 50 ohm is the more than the largest value. So what is the largest resistance here? 25. So it is obvious 50 is more than 25. So equivalent resistance is larger than the largest. So that we can see here easily. Now one more characteristic is that if we calculate the total power supplied by the circuit, so that total power will be equal to sum of power taken by each resistor. So how we can calculate total power? Again, we know the basic relation, electric power is equal to voltage into current. Now how much is the voltage here? Voltage is 100 volt, current is 2 ampere. So let me enter here. So total voltage is 100, current is 2. So if I take the product, voltage into current, as you can see, electric power is voltage into current. So 100 into 2, that is 200 watt. Now if I calculate power taken by each resistor, that is each light bulb, then if I add P1 plus P2 plus P3, it should be 200 watt. So for that, what we need to do? We need to measure voltage across each bulb and current flowing through each bulb. Now current, already we know that current flowing through each bulb is 2, and voltage already we have determined this, measured this value. So V2 and V3 already we have measured this. Now if I want to calculate the power, let me put the formula here. So 39.998 is the power consumption of first bulb, second bulb, $59.996, and third bulb power consumption is 99.992. So let us put these values here. Just a minute, I have to insert it as a value. So I have inserted P1, P2 and P3. Now if I add this, I should get 200. So for that, I will select this, click on auto sum. So as you can see, total power is 199.986, which is close to 200. So what we have observed here, if you calculate the total power supplied by the voltage source, that will be equal to sum of power taken by each resistor. That is, total power is P1 plus P2 plus P3 in our case. And one more characteristic we can observe here, if we go on increasing number of resistors in series, then current will reduce. So for that, what I will do, I will make little bit space here. I want to insert one more bulb. So let me delete this wire and take one more light bulb. Let me make more space, and now I will connect. Now this bulb is of 10 ohm. How was the earlier current? If you remember, it was 2 ampere. Now if I go on adding the resistances, current will go on reducing. So as you can see, current has reduced from 2 ampere to 1.67 ampere. Reason is obvious. As you go on increasing the number of resistance in series, equivalent resistance will go on increasing. So therefore, what is going to happen is the current, it will reduce, because by Ohm's law, total current or the supply current is voltage divided by equivalent resistance. Okay. So these are the various characteristics of series electric circuit. Now, one important thing, if you observe here, that this particular explanation is valid independent of number of resistors. So if you connect 3 resistors, 4 resistors, or any number of resistors, 2 resistors or more than that, then this explanation is also valid. One more thing is that, just for example, I am taking a DC system. Even if you take the AC system, then also all these characteristics will be valid. So summarizing, current flowing through each resistor is same. Second, total voltage applied across series circuit is equal to the sum of voltage across each resistor. Third, total resistance, that is equivalent resistance of series circuit, is equal to sum of individual resistances. In our case, R equivalent or R total is R1 plus R2 plus R3. Characteristic number 4, total resistance of series circuit is larger than the largest resistance in the circuit. That we have seen, total resistance of 50 ohm, it is more than the highest resistance, that is 25 ohm. Fifth characteristic, total power dissipated in series circuit is equal to the sum of power dissipated by each resistor. In our case, total power dissipated was 200 watt, which is sum of P1 plus P2 plus P3. And the last characteristic, sixth, as number of resistances connected in series increases, current flowing through the circuit reduces or decreases. So I hope you have understood the concept of series circuit and how we can use this particular tool, that is the PhET tool, that can be used for constructing various circuits. I would like to thank University of Colorado Boulder for providing this particular tool, which is free of cost, that can be used to understand complicated concepts. Thank you.